So last lecture we have discussed about the what is the algorithm, and here we are going to discuss on a analysis. Okay. So first I have talking about the type of the analysis. Okay. So first type is a time complexity, and second type is space. Wait a second. This second type is space complexity. Okay, so what is the time complexity? Time complexity based on CPU and cache memory. Okay, how much time take the CPU to run any program, and how much time to take the cache memory plus CPU take any to run the any program. Okay, so it's depend on the time complexity. Okay, and on a space complexity, that means you need any physical device. Okay, like hard disk. Okay, whatever you have saved in your program, any variable, any database you are using in a program and algorithm. Okay, so this is depend on the space complexity and save on the hard disk. Okay, so it's based on the hard disk and any physical device which are used to save your algorithm outputs and the. Okay, now we are going to discuss about the type. Okay, the analysis type. Okay, the first is a posterity. Okay, A is a silent, and second is a priori. Okay, priori analysis. So now we have to discuss about these two analysis type. Okay, I am talking about first the posteriori. Okay, so it is a dependent on language of compiler. What does that mean? Dependent on the language of compiler, that means you are using the C, C++, and Java and the Python. Okay, and these languages compilers have different time to run any program. Okay, so that's why it's so dependent on language of compiler. But if I'm talking about the priori, okay, so in this it is a independent. Why? Because we have checked out before the run on your system that algorithm. Okay, so that's why it is a independent. And in now algorithm tutorial and the algorithm course, we have only discussed about the priori analysis, not on the posteriori analysis, because posteriori done after the your code is completed. Okay, and you have created the algorithm and you have created the flow chart and you are taking the completely implemented your code in a completely in a particular specific language or Java or the C++, and after that you are running on a system and you have seen that how much time is taking. So this is the part of the posteriori. So because so that's why we are not using here. Okay, we are only focusing on the priori, because here we have written the algorithm and check out this algorithm is how much time is taken. Okay, so that's why we are focus on the priori. So if I'm talking about the priori also, so it is a given the approx result. Okay, approx result. Why I have discuss in our future. Okay, so let's escape this here right now. Okay, and next one is a have the same answer in every system. Okay, so these are parallelly equal. Okay, and I have to tell about you what is the difference between it. So the approximate result is that you are not given the exact result on your program. Okay, you have just given the how much time is taking, like a n square or n plus 2. Okay, so these time are taken by your algorithm. If I'm talking about the posteriori, that means your system when you run any program, so it's gives you the exact answer. Okay, if I'm talking about the same answer, so no, this is a different answer in every different system, because some system on a P4, some system maybe on a P6, some system on a i3, i7, i9. Okay, so these CPUs are fast to each other. Okay, if I'm talking about the i3 or i7, so i7 is a fast, so your answer is maybe some have the different. Okay, so the answer is running the very fast. Okay, so that's why it's a different answer in every different system. And if I'm talking about the priority, so it is the same in every system, because we are not running on the every system, we just assuming that your algorithm has given the output as some approximate value. So that why is the same answer in every system. So these are the type of the priority analysis. Okay, so now I have right now talking about the some example. So suppose I have written an example. Okay, and putting on the x 8 plus b plus 2. Okay, so how much statement in this program? Okay, so the statement is 1. Okay, so if I'm talking about his program algorithm complexity. Okay, so its a complexity is a omega 1. Now you asking me what is a omega, what is a theta, what is a big O. Okay, so it is a capital O is a annotation of the big O. Okay, so now I am talking about the annotations. What is the annotations? Okay, so these are the three annotations here. First is a big O, second is a theta, third is a omega. Okay, and we are specify, or the we are denote by the big O of the capital O, theta for the theta, and omega for the this sign. So these are signs are the represent the big O and the theta and the omega. Okay, so now I have talking about the big O. So let's me take an example. I have taken a graph. So suppose this is a fn and gn. What is the fn and gn? So suppose we are talking about the function fn, and function is equal to n square plus n plus 1. Okay, so now here is the values. Okay, yeah, maybe here is a -1, -2, -3, 0, 1, 2, 3, and so on. Okay, these are the value of the n. Okay, and now if you put in the n -1 here. Okay, so maybe your graph is going like here, and this is a point. This is the point where your values going only up, not coming up down. If you put here value like a -1 square plus -1 plus 1, so your graph covering here that value. So this is a gn. Okay, and at this point we have to donate by the n naught. What is the n naught? N naught means the n value always greater or equal to the n naught after this point. Okay, so this point is denoted by this function. Okay, so gn is showing this function. So now what does that means? So that means if you're talking about the big O. Okay, and I have talking about the function, and I have to write the complexity of time complexity of this function. So I am writing the big O of n square. Okay, because big O of n square, that means you have to greater than or equal. Okay, that means either this part is always greater than from this part. Okay, what does this mean? If you writing here n cube, this is okay, because fn function have that value fn plus n square plus 1, and n cube always greater than this function. So that's why I can also write that complexity of the fn like a omega, big O of n cube. Also I have write big O of n to the power 1000. This is also equivalent for here. Okay, but I have not write on the big O of n because here is the n square and I am putting on the n, and this condition is going to the false. Okay, so this is the notations. How can I write the denote the complexity of that function with the help of the big O? Okay, so I can write here. And if I'm talking about the same on the first I'm talking about the omega. Okay, and one of the things, always that function have that constant. Okay, and what is the constant I will tell you in the practice section. Okay, I will create that video on a practice, how can you get that time complexity of the particular program. So I will make the video from there. Okay, so on there I will explain all that things about the c constant. Okay, what is how we can use and what is the work of on here. Okay, so now I am talking about the omega. What is the omega? Omega means if you after the n naught your value always going down. Okay, so that means this is the omega of gn. Okay, and if I'm talking about here to donate fn in a omega mode, so you can write omega of n, omega of n by 2. Okay, so omega of n square. Okay, by because omega have that greater than or equal. Okay, that means always fn greater than or equal to the omega's value. If you write here omega of n cube, this is not valid for the fn function. Okay, because omega is greater than for the n square, so that's why you have to not write for in a fn function. Okay, so now I have to talking about the theta. What is the theta means? Okay, theta means when you are putting the some values on a this function, and some point your value is coming on a n greater than from the n naught, and some points your values coming on a below the n naughts on a same for the same function. Okay, so that means you have to write on a theta mode. Theta mode is that means you have to write for the equal. Okay, so you can easily write function is equal to theta of n square. That means the same function you have write theta, you have write omega, you have write big O. Okay, for n. Okay, so because always the is a below for the function. Okay, so that's why I am not taking any exceptions here. Okay, now the annotations are covered in the theoretical part here. Okay, and if you not have understood by that theory, okay, so take it easy. I will yeah discuss in the practical mode. Okay, so I have take the practice set for that time complexity, and there I will explain all that about the big O, omega and theta in a detail. Okay, so okay then